Hello pre-calc students, how you doing today? This is Mr. Law, Mr. Law's classroom. We are going over practice test. Unit 1. Alright, so you make sure you do full solutions on a lined sheet of paper like I have right here. And you're going to get 5 extra bonus points on your unit test as long as you staple that to your original practice test. We're going to start off with problem 1, and the problems are out of order because they pull different questions in order to have it better be aligned with your test today. And it says, what value of n would make this function continuous? And right now I see this is a piecewise function. And piecewise functions, in order for them to be continuous, you need to figure out at the x value where the two functions meet, they must share the same y value. So, looking at an example of showing your work for a problem like this, we have what value would make these functions continuous. We have the formula 1 on the interval x is less than negative 1, and formula 2 on the interval from negative 1, x is greater than or equal to negative 1, or less than or equal to 3. Alright? So when do functions 1 and 2 meet?
Negative.
Right? So when x equals negative 1, functions 1 and 2 meet at x equals negative 1. And when do functions 2 and 3 meet? So you got functions 2 and 3 meet when x is equal to 3. Now, f of x is continuous when the y values are at the same when the x values when the functions meet. So for the y values that have to be the same, that means x squared plus 1 has to be equal to n. That's for the y values being the same when functions 1 and 2 meet. So this is 1 and 2, when x is equal to negative 1. And n has to be equal to negative x plus 5 when 2 and 3 meet, when x is equal to 3. So you have x squared plus 1 equals n, and x is equal to negative 1, so we plug in negative 1. So x squared becomes negative 1 squared plus 1 equals n. Negative 1 squared is 1. 1 plus 1 is 2. 2 is equal to n. Alright? Negative x plus 5. N is equal to negative 3 plus 5. Plugging in 3. So you plug in positive 3 plus 5. Because negative 3 plus 5 and n is equal to 2. Because both when 1 and 2 meet, and when 2 and 3 meet, our value n here has to be equal to 2, the answer choice is going to be B2. Because that is the value that n has to be in order to make this piecewise function continuous. Alright. Now, any questions or things I can clarify before I move on to the next question? Yes?
Do we have to write the question?
You just need to be able to express the question so you can use your sheet of paper as a effective way to study. If you don't have the information down on what's presented in the question, it's going to be a less effective way to study for what's going on. Alright. Problem. All right, any other questions before we move on to the next problem? All right, remember, you can still ask questions. You can improve the quality of the recording when you have me answering your questions. All right, moving on to problem 2. All right, with problem 2, which function is increasing on the interval from negative infinity to infinity? So what you can do is actually graph these functions on Desmos. Alright? You graph what f of x is equal to x squared, and the function is going to look like what I drew on my sheet of paper. It'll look like a parabola. The function has to be increasing from negative infinity to infinity. looking at this parabola, I see the function is decreasing from negative infinity to 0. Because it is decreasing from negative infinity to 0, it means it's not increasing from negative infinity to infinity. So I can eliminate answer choice A. For answer choice B, f of x is equal to the log base 2 of x. I also graphed this function in Desmos, and just as a quick tutorial on how to graph logarithms in Desmos, I'm going to pull up Desmos. Alright. F of x is equal to, I go to functions in Desmos, miscellaneous in Desmos, log base b, where I input the log base 2 of x. And that is how I am able to draw my logarithmic function where it looks like so. And so I was able to draw the graph from Desmos by looking at the logarithmic function. Going back to the original function, right here, the logarithmic function is always increasing, if you can follow along. But while it is always increasing, it is only increasing from 0 not inclusive to infinity. Because it's only increasing from 0 not inclusive to infinity, it's not increasing from negative infinity to positive infinity. However, f of x is equal to 2 to the x. You graph this function, this is the exponential function. And while we have an asymptote at y equals 0, the function is increasing on all real numbers. Alright, so because the exponential function is increasing on all real numbers, it is the answer. Answer choice C is the correct answer. So C, f of x is equal to 2 to the x. D is the wrong answer because negative x cubed is going to look something like this. And this is decreasing. This is decreasing on all intervals, not increasing. Any questions at all or points of confusion that I can better explain about problem 2? What was that? Yeah. So yeah, I'm going to leave problem 2 up there. I'm going to continue on to problem 4. However, just because I'm continuing on to problem 4 does not mean you can also look at what's going on with problem 2. Alright. So, for problem 2, so let's go to problem 4 now. And problem 4 is a transformation problem, okay? What transformations occurred to create f of x is equal to negative 4x plus 8 from g of x is equal to 4x. So we need to analyze these transformations. So, are people still getting stuff down for 2? Mm-hmm. Alright, so let's analyze 4 here. We have g of x is equal to the square root of 4x, and then f of x is equal to the square root of negative 4x plus 8. We need to analyze all of these transformations. So we're going to do that. We can factor out our transform function to figure out what's going on. For f of x is originally negative 4x plus 8, but I can factor it into its transformation form to better understand what's going on. So when I factor it, I can get f of x is equal to the square root of factor out a negative 4, and I still have, and let's see what happens when I factor out negative 4. So my whole goal here is to factor out the coefficient of x. So what's the coefficient of x originally for f of x? What am I multiplying by x here? And for f of x originally? Negative 4. And so when I'm trying to factor out my function to get it into its transformation form, I always factor out the coefficient of x. So if the coefficient of x is negative 4, that's why I'm factoring negative 4. And when I factor out negative 4, what do I have left inside the square root? Well, let's look at the x term, okay? I have negative 4x and I factored out a negative 4. What's left over? Well, let's just look at the x. Let's just look at the x term first. When I have, if I factor out a negative 4, so let's look at the equation. Negative 4x plus 8. If I factor out a negative 4, I ultimately, what's left over is negative 4x divided by 4 and 8 plus 8 divided by negative 4. Alright, what's negative 4x divided by negative 4? X. So that's negative 4 factored out and an x, and what's 8 divided by negative 4? Negative 2, x minus 2. So when I factor out that negative 4, what gets left over is a negative 4x minus 2. Alright, I'm going to erase my work for factoring on negative 4. So one skill to practice, if you're unfamiliar with it or just rusty on it, is factoring. Factoring is a very important skill. Alright, so f of x is equal to negative 4 times x minus 2. And at this point, we can identify some transformations here. What does this negative sign indicate for function transformations? So that's right. This is a reflection across the y-axis. So make sure that you understand your function transformation rules. But this is going to be a reflection across the y-axis. A negative sign inside the function. Alright? This is a y-axis reflection. Y-axis reflection. T-I-O-N. Alright, and what about this negative 2?
It's moving to the right too?
Right 2, that's right. You shift right 2. Okay? What about this 4 here? Well, the original function was already the square root of 4x, not the square root of x. So because the original function was already g of x, alright, we can do this one in black. G of x is equal to just the square root of 4, and we can even say 4 times x. If we really want to put this out, we can do 4 times x minus 0, positive 4 times x minus 0. So we can really see we go from positive to negative and minus 0 to minus 2. That we have no change in this horizontal compression by 1/4. So there's already a horizontal compression by 1/4, and that doesn't change. So we shift right 2, and we have a y-axis reflection. And just looking at the work, we were reflected across the y-axis and shift right 2. Alright? I'm going to erase my stuff for 2 now. So make sure you've at least gotten your work done for 2. Any questions about any questions about problem 4 before I show it on Desmos? Alright, no. Alright. Is it okay if I clear annotations and move on to Desmos? Yes? Okay, I'm going to clear annotations and move on and show you guys how this reflection on Desmos. So, originally, g of x is going to be the square root of 4x. But we have a second function. And actually, this is g of x. We have a second function, f of x, which is equal to the square root of, and we're of negative 4x plus 8. Alright, and so we see, I can kind of see right here, the function is shifted right to and reflected across the x-axis. Or sorry, reflected across the y-axis. So let's analyze this step by step. First we just have f of x is equal to 4x, so it's going to be the same. I reflected across the y-axis. Alright, now it's reflected across the y-axis. And then I add 8, right, because it's negative 4x, do my reflection, plus 8, that shifts it right to. Also, this shows us why we can be confused if we don't factor things out. Once again, if things are factored out, negative 4 times x minus 2, that better shows our shift right to and our reflection across the y-axis. So if you can understand what's going on with Desmos, you can still get the function if you mess up on the algebra. But focus on getting the algebra right. Okay. Problem number 5. Alright, I'm going to zoom in here so you guys can see better. Zoom in some more. Okay, maybe not that much. So for number 5, we have g of x is equal to 1/2 times 3 to the x minus 2, and that's transformed from f of x is equal to, yes, Roy? Yeah, go ahead. 1/2 times 3 to the x minus 2, and that's f of x is equal to 3 to the x. So, let's analyze the function here. Alright, you originally have 3 raised to the x power, but then what happens to the x? What happens to our x term? How is it shifted? What do we alter to our, what we're adding or subtracting to our x term inside the function? Because we originally have just 3 to the x. How does that change? Then we have 3 to the x what? X minus 2. So what does that negative 2 do? It makes us move us to the right 2. And the reason why it moves us to the right 2 is, notice that this 2, right, this negative 2, this is inside the original function. Because this is inside the function. You can think of it as inside the function. Okay? Because it's inside the function, that indicates horizontal movement. So it's a horizontal shift. And horizontal transformations inside the functions do the opposite of what you think. Minus 2, right 2. Plus 2, left 2. But we have another transformation. What are we multiplying this 3 to the x minus 2 by? What are we multiplying this 3 to the x minus 2 by? By 1/2. So because we're multiplying by 1/2, we have our coefficient of 1/2. Yes. So with our coefficient of 1/2, notice I can draw parentheses around it and it still doesn't change anything. So that means that 1/2 is outside the function. So what type of transformation is this 1/2? Right, so we shrink by factor of what? Shrink, or we can shrink or compress by a factor of by a factor of 1/2. Alright? And so those are the transformations. Looking at our answer choices. We have compressed vertically and shifted right 2. So that's going to be answer choice B. This is answer choice B. We have shifted right 2 and compressed. Right? We have compressed, and we have a compression by 1/2. So we've had a compression and shifted right 2. A compression by a factor of 1/2. Alright, yes?
What's the difference between stretch and compress?
Alright, so a stretch means that you multiply the function. So check out my hands. My hands are together. I'm going to clear those annotations so you can see my hands here. So I'm going to clear annotations. These are my fingers, alright? So stretched means that it expands like that. Stretches out, stretches out. Compression means it comes back together. Furthermore, if you want to think about actually what's going on here, vertically stretched by a factor of 2. If the x inputs become the same, the y outputs get multiplied by 2. So, drawing a rough sketch of a graph, alright, you would have, let's say you had some sort of function where, let me do red here. Alright, you had an input of 1, 1, so you had an input of 1, 1, and then 2, 4. I don't know. 1, 1, and 2, 4. This 1, 1, 2, 4. This is not to scale at all. And then then let's say you stretched it by a factor of. So now let's draw a stretch. A stretch then would have an input value of. Let's say you stretched by a factor of 2. You had a value of 1, 2. So actually, to make this accurate, you would have 1, 2, and then 2, 8. This would be a stretch by that factor. And the function would look like same point, but then it would go like there. And if you had a compression, you would have a point of 1, 1/2, 2, 2. Once again, this is not to scale at all. I'm just trying to understand this conceptually. And that would go through the function like that. So essentially it's what you're multiplying the y terms by without affecting the x. That's for vertical stretches. Now for horizontal stretches or compressions, it's the opposite. You're multiplying the x term without affecting the y term. Alright, so that was 5. Let's move on to 6. Alright. Alright. We have g of x is equal to negative x squared minus 9 from f of x equals x squared. Find the transformations. And so this one I'm going to pick up the pace a little bit here. You start out with x squared, and let's look at the transformations we make to x squared. This becomes negative x squared minus 9. What does that negative sign do? Well, is the negative sign inside or outside of the function? It's outside. So what type of reflection is that going to be? It's going to be an x-axis reflection. Alright, and then what does that negative 9 do? Down 9. So remember, that negative sign is outside of the function, and because it is outside of a function, it is going to affect the x-axis, not the y-axis, and that minus 9 is also outside the function, so we're going to shift vertically down 9 instead of horizontally right 9. Down 9. Now, if this were to have a y-axis reflection, this is what a y-axis reflection would look like. The y-axis reflection would look like this. You would have your negative sign inside your x term. That would be a y-axis reflection. So the negative sign is inside. And if you had to shift down, if you had to shift, let's say, right 9, shifting a function right 9 instead of down 9, once again, that shift would be inside the x terms. So if you wanted to do a y-axis reflection right 9, that would be negative x minus 9 squared. So that would be a y-axis reflection right 9. So be careful about factoring things out. Once again, you can also do this on Desmos. In Desmos, it's very easy to see. You've taken your standard parabola, shifted across the x-axis, shifted down 9. The function looks like this. Yes.
Can I just listen?
Yes, you may. Alright, where this point is 0, 9. Alright, so that was problem 6. Any questions on problem 6 before we move on? Alright, make sure we're engaged in trying our best here. Alright, problem 7. Let's remove that cord up. We can show problem 7. Clearing annotations. Alright, problem 7. And I'm going to give me an opportunity to show some more work here. Alright, so f of x is equal to the negative 2 times the cosine of 3x. And this seems daunting because it's a trig equation. But if we know our transformation rules, we really see this is just like any other transformation problem, and the trig function is actually not relevant. And g of x, we go through some sort of transformation, and then g of x is equal to negative 2 times the cosine of 3x plus pi over 3. Alright? Now, we have to factor, okay? We have to factor in order to figure out what our changes are. So, fully annotating our transformation changes for f of x, this will become negative 2 times the cosine, and we're going to factor out that 3. Because we always factor out the coefficient of x. 3 factored out of x, nothing's being added to x, so I'm going to add an x, plus 0, and then nothing's being added on at the end, plus 0. Completely factoring out g of x, we have negative 2 times the cosine of 3, and now we factor out that 3. And we factor out that 3. Let's factor out. Let's factor 3x plus pi over 3. Let's factor out a 3. So if we factor out a 3, what's left? What do we divide each term by in this sum here? If we factor out a 3. If we factor out a 3, what are we doing to each term? What do we do to each term in order to, when we take a 3 out of it? We divide each side by 3. So you have, if you take out a 3, you're dividing each term by 3. 3x divided by 3 plus pi over 3 divided by 3. Alright, what is 3x divided by 3? So this becomes 3 times the first term is x. What about pi over 3 divided by 3? So how would we do pi? So we need to. It's you just have to know how to divide fractions. You just do. All right. Pi over 3 divided by 3. What's the denominator of 3? If I just have a regular number, what's its denominator? 1. So pi over 3 divided by 3 over 1 is pi over 3 times 1 over 3. Keep change. Pi times 1 is pi. What about 3 times 3? 9. So pi over 3 divided by 3 becomes pi over 9. So that's x plus what? What's pi over 3 divided by 3? What's pi over 3 divided by 3? We just did it. Pi over 9. Okay. So we factored out that 3. So we have negative 2 times the cosine of 3 factored out of x plus pi over 9 plus 0. Okay? And a red arrow, this is going to indicate no change. Alright? So we have a reflection across the x-axis, but we have no change because we still have a reflection across the x-axis when we go from f of x transformed into g of x. We have a vertical stretch by a factor of 2, but there is no change because we still have that vertical stretch by a factor of 2 when we go from f of x to g of x. We have a horizontal compression by a factor of 1/3, but there is no change because we still have that horizontal compression by a factor of 1/3 when we go from f of x to g of x. But this is where there is a change. There is a change when we go from x plus 0 to x plus pi over 9. So we have plus pi over 9. So what does this plus pi over 9 indicate? Right? So we're going to move left pi over 9. Left pi over 9. And then there's no change from having no vertical shift to no vertical shift. So our only real transformation here is moving left pi over 9. You can check the work. I did the same work here on with the work I did on my piece of paper here above. So the answer choice is going to be B, left pi over 9. So left pi over 9, that's going to be answer choice B. B, left pi over 9. Okay. Alright, ask your questions. Yes, Claire?
Can you go back and explain why you factored the 3?
Okay, I factored the 3 out so I can get x by itself. I want to get x by itself by any means necessary. So, because I have 3x plus pi over 3. I want to get this into function transformation form. Remember, full function transformation form is plus or minus a times f of b plus or minus b completely factored out of x minus h plus k. And I tried to completely factor out my terms so I can very easily identify my transformations. If this is a positive, there's no x-axis reflection. If this term is negative, there's a x-axis reflection. If a is greater than 1, it's a vertical stretch by that factor. If a is a fraction, it's a vertical shrink by that fraction. If this is a positive sign, there's no y-axis reflection. If there's a negative sign, there's a y-axis reflection. If b is greater than 1, there is a horizontal shrink by 1 over b. If b is a fraction, there's a horizontal stretch by 1 over 1 over b. If you have a horizontal shift by h, but then you switch the sign because you have a negative sign in front of it, and you have a vertical shift by k. And so that's everything you know about a functional transformation form. But in order to get into that form, you have to factor out b, which is the coefficient of x. So that's why I do it. You can also use Desmos and just see what's going on when you literally transform the function as you type the old function in the new function. Alright. Am I good to clear annotations, or are people still writing things down? Alright. I'm going to clear annotations. This is going to take a while. I'm also going to clear objects. Okay. Alright. Number 9. What is the inverse of h of x is equal to the cube root of x minus 3? So I need to find the cube root of x minus 3. So what do I do with an inverse problem? What do I first switch? X and y. So if h of x is equal to the cube root of x minus 3, I now make x equal to the cube root of y minus 3. And then I need to isolate y. Add 3 to each side. Add 3 to each side, and now I have x plus 3 equals the cube root of y. My next step is to cube both sides to isolate y, get rid of that cube root. So I am cubing both sides, and I end up with x plus 3, the whole thing cubed. That is equal to the inverse of the function. And this is answer choice A on your sheet. Okay? So I do think it is easy, but you just got to make sure that you understand the steps correctly so you don't make a silly mistake. All right? I want you to see this question on a test and not mess it up and be like, "All right, this is a gimme, Mr. Wall. Thank you." All right.
What is equivalent to x plus 3 squared?
X plus 3 cubed.
Yeah, that's not
That's the inverse of the function. So you're solving the inverse. So remember, with an inverse, you switch the x's and the y's, and then you try to isolate the y. So isolate the y. First I added 3, getting the y term by itself. Then I cubed each side, because cubing something that is cube rooted cancels out the cube root. All right. Other questions, because you make sure you understand the fundamentals of your step-by-step process. Questions on what's going on. So make sure that you are asking questions. Make sure you're fully on task right now. You know who you are. All right. Problem 10. Alright, find the domain of the inverse of the function when the original function is x plus 3 over x minus 2. Okay, this one I'm going to make a rectangle over it. Okay, so if f of x is equal to x plus 3 over x minus 2, what's our first step for finding an inverse? So switch the x and the y. So x is equal to y plus 3 over y minus 2. Well, what's our first step here?
Multiply both sides by y minus 2.
Right? So I'm going to multiply both sides by y minus 2. So I will have x times y minus 2 on the left side and y plus 3 over y minus 2 times y minus 2 on the right side. What happens on the right side? Y minus 2 cancels out. Let's go to red. Cancels out with y minus 2. And what happens on the left side?
It just distributes.
We have to distribute the x. So x times y
xy
and x times negative 2
negative minus 2x.
minus 2x is equal to y plus 3. What's our next goal?
Subtract from y and then add the 2x.
Alright, so why are we doing that?
So we can get them on each side.
We have to, what specifically are we trying to get on each side?
The y's.
All terms with a y in it, we need to get them on the same side. So I'm going to add 2x to each side and subtract y from each side. So I get xy minus y. Xy minus y is equal to, so 2x plus 3. 2x plus 3. So what happens is that the y and the minus y cancel out. The negative 2x and the positive 2x cancel out. So I get xy minus y, and 2x plus 3. So my last step is going to be to factor. So if I factor out a y on each side, what's left? X minus 1. And that's equal to 2x plus 3. Now I have to divide each side by x minus 1 to isolate y. Divide each side by x minus 1. Yes. Yes. The x minus 1's cancel out. And so the inverse of the function is equal to 2x plus 3 over x minus 1. Now, this is the inverse of the function. But what are we asked to find? How do we find the domain of this inverse? How do you find the domain of a function? What are we thinking about when we try to find the domain? So the domain's all of the x values. So how do we determine what's in the domain and what is not in the domain? What will we do? What will we do? Alright, what will we do? How do we find the domain? What situation would make the universe explode? Okay, so how do we find the x values that would how do we find our x restrictions so we make sure that doesn't happen? Set the denominator. Okay? So x minus 1, the denominator cannot equal 0, which means that add 1 to each side, x cannot equal 1. So how do we express this inequality or inequality in interval notation? Negative infinity to 1, good. Union 1 to infinity. Excellent. Alright. Clearing annotation. So that is the domain. That is the domain of the inverse. So we have to take the inverse and then treat it like any regular function and find the domain of it. So that's kind of a two-step problem. One, be able to take the inverse. Two, find the domain of any function. Alright. Should I give you guys some time before I clear the page? Yes? Yes? Yes, okay. Alright, I'm going to give you guys a little bit more time. Alright, here, get the rest from the video. I'm going to clear annotation so I can get through all the problems by the time class ends. Alright, so we just found that domain. Now we're going to go work on problem 11, okay? For 11, f of x is equal to negative 4x plus 2. G of x is equal to the square root of x minus 8, and we need to find when f of g of x is equal to negative 6. So g of x is our internal value. So I'm going to start with it first. G of x is the square root of x minus 8. And I want you to practice using this verbal language. F of x is equal to negative 4x plus 2. Which means when you plug an input into f of x, it gets multiplied by negative 4, and then you add 2 to it. So, if our input is g of x, and g of x is the square root of x minus 8, what we do is we take the square root of x minus 8, we multiply it by negative 4, and then we add 2 to the value. And f of g of x is equal to negative 6, so this is f of g of x. It's equal to this. But we need to find out what value of x happens when this is equal to negative 6. So we need to figure out when this term is equal to negative 6. Let's use some algebra. First, I'm going to subtract 2 on each side. So I have negative 4 times the square root of x minus 8 is equal to negative 6 minus 2. That's negative 8. Then divide each side by negative 4. Negative 8 divided by negative 4. Those negative 4's cancel out, and negative 8 divided by negative 4 is positive 2. So that's going to be equal to the square root of x minus 8 is equal to positive 2. Alright, now I square both sides. I squared both sides. 2 squared is 4. So x minus, and squaring cancels out the square root. X minus 8 is equal to 4. I add 8 to each side. 8 plus 4 is 12, and so x is equal to 12. X equals 12. Alright, and so that is the solution. You can also follow all my work on the piece of paper above. Alright. We are now... Yeah. Yes, you may.
Where'd you do this?
Okay, so the question originally says, for problem 11, when does f of g of x equal negative 6? So you have to find the composition, set it equal to negative 6, and then solve for x. Okay? Alright, moving on to problem 12. Alright, if f of x is equal to 3x squared minus 2 and g of x is equal to the square root of x minus 9, find f of g of x. Okay? So, what we do here, we plug in g of x into f of x, so we take the square root of x minus 9, that is g of x, and we're f of g of x, so this gets plugged into f of x. Conceptually verbalize this. F of x is equal to 3x squared minus 2. G of x is the input. With f of x, you take the input, you square it, you multiply it by 3, and then you subtract 2. So I take the input, I square it, then I multiply it by 3, and then I subtract 2. The square root, what's the square root of x, the square root of x minus 9? Squared. So when I square it, it cancels out the square root. So now I just get 3 times x minus 9 minus 2. 3 times x is 3x. 3 times negative 9 is negative 27. Negative 27 minus 2 means that 3x is negative 27 minus 20. Negative 27 minus 2 is negative 29, so that becomes 3x minus 29, and that's the final solution. That's going to be answer choice D. That's equal to f of g of x. 3x minus 29. All right. Questions? All right. I'm going to clear annotations and move on. Notice all the work is also on the white sheet of paper they have projected. Okay, yes. Yes. All right. Now, 13. Find f raised to the negative 1 of 1/2. So find the inverse. So find when the input into the inverse function is 1/2. Find that when the original function of f of x is equal to x plus 2 over x minus 4. Alright, so let's do the step by step. Draw our rectangle. Okay, so first of all, f of x is equal to x plus 2 over x minus 4. Sorry, x minus 4. So what's our first step for finding the inverse? Because first we need to find the inverse, then we need to evaluate it. Right? So x is equal to y plus 2 over y minus 4. First step. Right? So you have y minus 4 times x equals y plus 2 over y minus 4 times y minus 4. What happens next? Y minus 4 cancels out. So we get, distribute the x, xy minus 4x. Xy minus 4x equals y plus 2. Alright, next step. Good, because we're trying to get all our y terms by itself. So I'm going to, well, yeah. Sorry, you can either add 4x and subtract y on each side, or subtract xy on each side and subtract 2. Your call. We want to get all our y terms on the same side of the equation. So we want to get these y terms on the same side of the equation. Choose one method to do that. We're gonna add 4x to each side. And if we add 4x to each side, that means we also have to subtract y from each side. Subtract y from each side. The negative 4x's cancel out. Swing. So the y's cancel out. Swing. And you have xy minus y equals 4x plus 2. Okay? So let's set up the equation at the top. Give us a little bit more space. xy minus y equals 4x plus 2. Alright, what are we going to factor out now? Factor out that y on the left. What's left? Right, because xy divided by y is x. and negative y divided by y is negative 1. Because that's what we're doing here. By taking out that y, we're dividing each term by y. Equals 4x plus 2. The last step to isolate y is to divide each side by x minus 1. So y is equal to 4x plus 2 over x minus 1. Now this is the inverse. So we need to find what happens when you find, if that's the inverse, we need to find the inverse of 1/2. If our input is 1/2, we get 4 times what? 1/2 plus 2 over 1/2 minus 1. So what's 4 times 1/2? 2 plus 2. And 1/2 minus 1. So that's 4 over divided by negative 1/2. So what's 4 divided by negative 1/2? Negative 8. So 4 divided by negative 1/2 is negative 8. Verify your calculator. Dividing by a fraction makes something larger. And so the answer is equal to negative 8. And I believe that is answer choice C. Alright. Okay, 2 more problems and 10 more minutes. So we have 5 minutes of problem. That is actually, the timing is working out perfectly. Make sure you are engaged on task. You know who you are.
Wait, how'd you get negative?
Okay, so my last part I got 4 divided by negative 1/2. And 4 divided by negative 1/2 is negative 8. Because I had to once I found the inverse, I had to plug in 1/2 for x, because it told me to find the inverse of 1/2 as the input. Alright, clearing annotations. Clearing objects. Alright, problem 3. Alright, we need to find the domain. We need to find the domain of f of x when f of x is equal to x squared minus 3x plus 2 over x squared plus 2x minus 8. So f of x is equal to x squared minus 3x plus 2 over x squared plus 2x minus 8. Alright? What do you think we should do first? Factor, okay. You can factor the so let's factor the numerator and the denominator. We know we only have to factor the denominator, but let's just do both. Alright, what's the numerator factored? We need 2 terms that multiply to 2 and add to negative 3. Not just 2 and 1, negative 2 and negative 1. So that's going to be x minus 2 and x minus 1. Alright? And what about the denominator? I need 2 terms that multiply to negative 8 and add to positive 2. It's positive 2. So what term is going to be positive? Positive 4 and negative 2. 4 minus 2 is 2. 4 times negative 2 is negative 8. So that's going to be x plus 4 and x minus 2. And, well, it seems like these cancel out. You keep it there for domain. Because with domain, what's the issue here? What do we have to make sure? We need to make sure that we are dividing by 0. We cannot divide by 0. So, our denominator cannot equal 0. X plus 4 times x minus 2 cannot equal 0. Which means, if either one of these terms are 0, the denominator is equal to 0. So, x plus 4 cannot equal 0, and x minus 2 cannot equal 0. Subtract 4 on each side. X cannot equal negative 4. Add 2 on each side. X cannot equal positive 2. Now, next step. How can we express these inequalities in interval notation?
Negative infinity and negative
negative infinity to what?
-4.
Right? Union,
-4 to
-4 to 2, union, 2 to infinity. That is the domain. Alright. Get your notes down. We have 6 minutes to do the last question. And then we're going to be doing math bell to bell. That's what I like. Clearing. Oh no, let's give you guys a little bit more time. Also, at this point, it is time to ask questions. So, question away while you people are still getting things down. Alright, so questions. Any questions at all? Alright, guys. We have one more problem to do.
Yes.
Alright, clearing this page, alright? Alright, so with problem 8, we need to find the symmetry, which means find out whether the function is even or odd when you have f of x is equal to 3x to the 5th minus 2x cubed plus x, okay? And so, you can, here, on the video, or you can watch on the screen right now, you can see my work to see, find f of negative x, find negative f of x, see that f of negative x is equal to negative 3x to the 5th plus 2x third minus x, and negative 1 times f of x is also equal to negative 3x to the 5th plus 2x cubed minus x. And the definition, the algebraic definition of an odd function is that f of negative x is equal to negative f of x. So the answer is D. The algebraic definition of an odd function is f of negative x equal negative f of x. And I did this by finding f of negative x, finding negative f of x, and seeing if they were equal to each other. Now, just a heads up, an even function is f of negative x equals f of x. So if you find f of negative x and it is equal to f of x, then the function is even. But I want to do one more test on Desmos before you go. Because this is going to very easily help you determine whether a function is even or odd. Yeah, let me... guys.
Can I get another copy and give to Jacob?
Yeah. We still have... We're going to do... It is 12:06. We have 3 minutes left. Still get your notes down. We're going to do our Desmos example for the next 2 minutes, and then you will have 1 minute to pack up after I end the recording. Alright? Remember, you turn it on the day of the test. Yeah. Alright. So, am I good to clear the page now? Alright. So going to Desmos. Alright. Yep. Alright. You keep the warm-ups because you need to study Friday's problem, because those will also be on your test. So study Friday's problem. Okay? Because I want you to keep those so you can study that. The equation is 3x to the 5th minus 2x cubed. Guys, stay in your seats. Stay in your seats. Minus 2x cubed plus x. Alright? One thing you need to know about odd functions is that they are reflected about the origin. If you look at this function, you see it is reflected about the point 0, 0. Also, looking at the grid of inputs and outputs, notice you have f of negative x equals negative f of x. By the way, looking at the pattern, you have an input of 1 and an output of 2, an input of negative 1 and an output of negative 2. So if the only change for your inputs are the negative, the only thing that changes for the outputs is that the signs are switched. Same thing, an input of negative 2, an output of negative 82, an input of positive 2, an output of positive 82. So once again, looking at the inputs and the outputs, you can clearly see this is an even function, this is an odd function. Alright, have a great day.